In this video, we're going to talk a little bit about function notation. I'm going to focus on using function notation, what we do with it. Before I do that, I just want to do a little bit of review about function notation in general, then we'll pop into some examples. In this video, we're going to use this one function, f of x equals 3x squared minus 7. So a quick reminder of the parts. This first part here, f of x. Again, we read this as f of x, and it is not f times x. That's important. It may look, that's the way we write when we put something out in front of the parentheses, but for this function notation, we're saying this is a function of x. This x is my input value. This f of x is my output value. So we're kind of putting it all in one complete package. Now we look at whatever I have in here for my input. I plug that into the equation wherever I have the x in the equation. And that's what I would do. This is what I do to try to find my output. This is just the name. It's the function f with an input x, and it says what that value equals. So let's find a few of these. So let's just start pretty simple. Find f of 2. 2 is my input, so I'm going to plug 2 everywhere there's an x in my equation. So that's 3 times 2 squared minus 7. Then order of operations, I'm going to do my squaring first. So 2 squared is 4. 3 times 4 is 12. Minus 7 is 5. So I would read that as f of 2 equals 5. If my input is 2, my output is 5. Or there's my x, here's my y, if I'm looking at this on a graph. If I say f of negative 4, I do the same thing. Here's my input, I plug it in for the x. 3 times negative 4 squared minus 7. Again, I square the negative first, so I get 16. I would double check that you're doing this correctly on your calculator. If you plug this into the calculator again, if you type negative 4 squared without the parentheses, you get a negative value, negative 16. That's not what we want. We're squaring the negative 4. This is saying square it first, then make it negative. So 3 times 16 is 48, minus 7 is 41. So f of negative 4 equals 41. Again, the nice thing about this function notation is when I give that statement, f of negative 4, I know I have the function f. I know my input is negative 4, and I know my output is 41. I got a lot of information in this one simple statement. I can also do some funky stuff with this. Let's try this one. I want to know what f of x plus 1 equals. What do you mean f of x plus 1? What are you messing with other stuff with? Well, it's really doing the same type of idea. This x plus 1 is the input, so it goes everywhere there's an x. So I take, instead of x, I plug in x plus 1, and I square it, minus 7. And for right now, I'm just going to leave it like this. I have a new equation now to deal with. I have a little different input. I can come along and let's go f of 3x minus 7. I'm just going to do the same thing. Where the x is in the equation, I'm going to put my input, 3x minus 7. I'm getting too many 7s in here. Or if I really want to mess you up, I'd say, well, let's try f of w. Well, f of w is just 3 times w squared minus 7. We just changed the variable name. But this function notation allows us to do some more of this. We'll look at this type of idea right here. We'll look at that later on. I can also flip things around. I could give you this problem. It's always better with sound effects, right? Okay, I could say f of x equals 41. Find x. Well, in this case, I gave you the output. I want to find the input. So the output is f of x, 41. That's 3x squared minus 7. Now I just solved this equation. I'll add 7. I'll divide by 3. I will take the square root. Again, when I take the square root, I get the absolute value. So the absolute value of x equals 4. So x is going to equal 4, or x is going to equal a negative 4. Okay, well, shall we check this out? Actually, we already checked one of these out because, or did we? Yeah, I just did f of negative 4 on the previous slide. Yeah, f of negative 4 equals 41. That checks. I can also work with this function notation inside other equations. So here I have an f of 3 here, f of negative 7. To get 5 times, in this case I am multiplying 5 times f of 3, and I'm taking 2 times f of negative 7, and I'm subtracting those. So let's figure out what those two are. F of 3 is going to be 3 times 3 squared minus 7. 3 squared is 9 times 3 is 27. Minus 7 is 20. F of 3 is 20. F of negative 7 is 3 times negative 7 squared minus 7 is 3 times 49 would be, that's one, let's work on that. That's 147 minus 7 is going to be 140. Is my f of negative 7. So I now just plug these in. 20 goes there, 140 goes there, and I have 5 times 20 minus 2 times 140 is 100 minus 280 gives me a negative 140. So I can work with these in any equation I'm given. It just says kind of like order of operations. What do I do first? Let's maybe sum that up with an order of operations idea. You might be used to thinking about, your good old please excuse my dear Aunt Sally. Or you might remember as PEMDAS. And parentheses is our P is parentheses, E is exponents. Whoa, boy, let's undo that. We have multiply and divide. We have add and subtract. We do those left and right. And when we put this function notation in here, we are going to start with our parentheses. But instead of E, I'm going to put an F for, or I'm going to change E, let's say, to evaluate functions. Because squaring exponents are actually a function. So when we do an exponent, we are really evaluating a function. But now this includes absolute value, it includes square roots, it includes using everything with function notation. First we do the parentheses, because especially with the function notation has parentheses, so if there's something inside of that, you have to do that before you go any farther. But you do inside the parentheses, then you evaluate the functions, then you go on to multiplying and dividing, and adding and subtracting as normal. So we can still use our order of operations. It just kind of fits in there nicely.